Many people think Neptune is the coldest planet in our solar system. It is the farthest from the Sun. It looks icy blue. It drifts at the dark outer edge of space. By simple logic, it should be the coldest. But that assumption is wrong. The coldest planet in our solar system is not Neptune. It's Uranus, a planet closer to the Sun, receiving more sunlight, and yet reaching temperatures lower than anywhere else we have ever measured on a world in this solar system, minus 371 degrees Fahrenheit, the lowest atmospheric temperature ever recorded on any planet. And we still don't fully understand why. To see why this is strange, you need to understand something most people never think about. A planet's temperature isn't only determined by how far it sits from its star. A planet's atmosphere is heated from two directions at once, from above by radiation from the Sun, and from below by heat rising from its own interior. When giant planets form, the collapse of gas and rock under gravity generates enormous thermal energy. That heat doesn't disappear. It bleeds outward over billions of years, rising through the atmosphere, driving weather, keeping the upper layers from reaching the coldest possible extremes. Neptune still does this. It radiates roughly 2.5 times the solar energy it receives. That internal heat fuels the fastest sustained winds in the solar system, exceeding 1,200 miles per hour. The most powerful hurricane ever recorded on Earth peaked at around 215. Neptune's atmosphere is being pushed from below, constantly, by a planet still cooling from its own birth. Uranus emits almost nothing. Measurements show Uranus radiating back roughly the same energy it receives from the Sun. No internal contribution, no excess heat rising from below. For a planet of its size and composition, this is abnormal. Something suppressed the heat that should be there. Without that rising warmth, the upper atmosphere has nothing pushing back against the cold of space. It just keeps falling. Minus 371 degrees Fahrenheit. Colder than Neptune. Colder than anything. Now add the second layer of strangeness. Uranus rotates at 98 degrees off its orbital axis. Earth tilts at 23 degrees, enough to give us 4 seasons. Saturn tilts at 27. Uranus is essentially lying on its side, rolling around the Sun like a barrel rather than spinning upright. For half of its 84-year orbit, one pole faces the Sun in continuous daylight. The other sits in unbroken darkness. Then the situation reverses. Entire hemispheres experience winters that last for decades. Earth's day-to-night temperature swing is around 10 to 15 degrees in most places. A polar region of Uranus cycles through one of the largest seasonal contrasts in the solar system over the course of a human lifetime. When Voyager 2 flew past in 1986, scientists expected to see the atmosphere actively responding to decades of direct sunlight on the southern pole. Instead, it was nearly uniform, featureless, calm, a planet that ignores its own seasons. The leading theory ties both mysteries together, the missing heat and the impossible tilt, and it begins with a catastrophe. Sometime in the early solar system, 3 to 4 billion years ago, an object at least as large as Earth struck Uranus. Not a glancing blow, a full collision, powerful enough to knock the planet completely onto its side. Under current models, that impact may have created a dense internal layer, a kind of thermal lid that traps heat rising from the core before it can reach the surface. The heat is there. It has to be, but it can't get out. It stays buried, invisible, while the atmosphere above freezes. A planet hit so hard it may have lost the ability to warm itself. Voyager 2 reached Uranus in January 1986, after 9 years of travel across the outer solar system. The encounter lasted a few hours. What it found barely scratched the surface. The first surprise was the rings. Astronomers had discovered them 9 years earlier, in 1977. entirely by accident. A team was using Uranus to time the passage of a distant star, watching the starlight dim as the planet moved in front of it. What they didn't expect was that the light flickered before the planet even arrived, and again after it passed. Something was orbiting Uranus, something thin, dark, and nearly invisible from Earth. Uranus had rings. Nobody had been looking for them. Nobody had predicted them. When Voyager 2 arrived, it photographed them up close for the first time. Narrow, dark bands, unlike Saturn's broad, reflective belts. Made of some of the darkest material in the solar system, as black as charcoal, absorbing nearly all the light that hits them. Even knowing they were there, you could barely see them. A ringed planet that hid its rings for centuries. Voyager 2 also discovered something wrong with the magnetic field. On Earth, the magnetic axis runs roughly through the geographic poles. On Uranus, the magnetic axis is tilted 59 degrees away from the rotation axis, and it doesn't originate from the planet's center. It's shifted toward one pole, asymmetric, irregular. No other planet in the solar system has a magnetic field this misaligned with its own spin. The consequence is a magnetosphere that tumbles and rotates in an irregular pattern as the planet moves, not sweeping space cleanly, but twisting unpredictably with every rotation. We don't know why. Voyager 2 also photographed the moons. Among them, Miranda, just 480 kilometers across, roughly the size of France. Its surface looks like it was shattered and reassembled incorrectly. Fractured terrain, impossible canyons, and Verona rupees, a single cliff face rising 20 kilometers from base to rim. More than twice the height of Everest on a world barely large enough to hold itself together. If you stood at the edge and dropped a rock, it would take around 10 minutes to reach the bottom. On Earth, the same fall takes less than 10 seconds. Miranda was probably shattered by an ancient impact, possibly connected to the same event that tilted Uranus itself, and collapsed back under gravity. A moon rebuilt from its own wreckage. In 2023, the James Webb Space Telescope turned toward Uranus. The images were unlike anything Voyager 2 had captured. The rings appeared in full detail, bright, structured, revealing far more material than any prior image. In a single JWST frame, you could see what decades of ground-based observation had missed entirely. And at the poles, something else. Faint glowing arcs, auroras, driven by charged particles interacting with that tilted off-center magnetic field. Not the clean oval auroras of Earth or Jupiter. Asymmetric, irregular, following the geometry of a field that points nowhere predictable. A planet with auroras that don't follow the rules. In 2022, the National Academies of Sciences released its Planetary Science Decadal Survey, the document that sets NASA's exploration priorities for the coming decade. For the first time in the survey's history, the top-ranked flagship mission was not to Mars, not to Europa. It was Uranus, a dedicated orbiter that would spend years in orbit, not hours. Probing the atmosphere, mapping the interior, studying the moons, trying to answer what a few-hour flyby left open in 1986. If it launches on schedule, it arrives around 2045. By then, nearly 60 years will have passed since anyone looked closely at the coldest world in the solar system. Uranus is colder than Neptune not because it's farther from the Sun. It isn't. It's colder because something silenced the heat it was born with. A collision that tilted a planet, fractured a moon, buried a thermal engine, and hid a ring system in plain sight for centuries. We called it the boring planet, the featureless one, the one with nothing interesting to show. The solar system doesn't care what we call things. And the worlds we dismiss first are usually the ones that have the most to hide.